As always with my workshops, these are intentionally informal. I've thrown together a bunch of thoughts, not necessarily in entirely linear order because there's no real straight line from here to there. And I'm going to, if left to my own devices, I will move at between elementary and advanced and then back to intermediate and all around. Leap in whenever you guys want. I'm more than happy to answer as any questions I can. I suspect that there's, as with everything, there's different ways of doing things in R. There's the core fundamental ways on which everything else is built. And then there's layers on top of it, which for some people make things easier, for other people they make things actually harder later on. We can discuss these trade-offs. It's curious. I wonder where half my slides have gone. It says I've only got 11. We'll see. But just this is a free for all. Just ask questions, yell, disagree with me, agree with me. What I'm partially trying to get at here is stuff that, one goal is simply this, and it depends on who the audience is. I suspect you're self-selecting, so so writing an R package isn't that daunting. Okay, one of the things I'd like to be able to do is actually get all the people who self-selected not to come and say, actually, writing an R package is trivial, and I can do it in 3 to 4 minutes, depending on how fast I type. It's really, really straightforward. But there's a lot of gotchas along the process, from beginning to end, and more to the point, sort of the high-level stuff, that not the syntax, not the mechanics, but actually the philosophy behind some of these things is actually useful to discuss. And more to the point is so the experience of the software experience and software development. So we're just going to talk about packages today. Here's a question: who in any class has learned about packages, about not writing an R package? Okay, that's kind of what I expected. Any in a workshop tutorial? Where?
Actually, someone in the lab can give a talk.
Okay. Okay, excellent, good, that's terrific. And then I did actually, I named this working with, I didn't creating, but it's not just creating packages. There's kind of fun stuff to actually think about, which we'll start with, which is just actually how you manage packages. A little bit, just some elementary stuff for everyone who knows about it. Most people don't, they have to use one. Okay, I say the count on slides is a lot different. So what's a package? Okay, does anyone know what a package is? No. Good. Excellent. Excellent. It's a unit. Probably the most important thing is it's an installable unit. Okay, it's a distributable. Who cares about that? It doesn't have to be distributable. It can be entirely on your own machine. It need never leave your machine, so that we don't care about sharing it necessarily. But it's a single collection of things. Okay, but it's an installable unit, but it doesn't have to be functional. You'll actually find that there are packages which contain only data. Okay, nothing but data. There's a single function in some packages, which is actually kind of a cool thing. We can use this to actually share data, okay, and distribute data with versions and all sorts of stuff, so people can actually reason about it, computationally reason about what version they have and what is the most recent, or go back and get the previous version and all that sort of stuff. And so it can actually be a collection of data objects and or functions. We don't need functions, which is kind of weird. Everyone just assumes they're functions. Nearly always it's a collection of functions, but in some packages you actually have objects that are that are actually part of the package, not part of the data part of the package. So we tend to put data sets in a different part of the functions, but sometimes we even have objects there. Nearly always, if you ever see a package out in the wild that you didn't write, it should have documentation, but it's not a requirement. You can install a package without documentation. I say that because that really lowers the bar. Okay. I'm happy if I don't have to write documentation, because that's the really boring part. Okay, whereas if I have to, that's annoying. But we typically have documentation. But this is the critical thing. It's easy to install. It is trivial to install, and it's getting even easier because we have a variety of different mechanisms. We can download it off the web and install it locally. We can download it directly from the web and install it all in one go. R has mechanisms. We can use a shell. We can use use R. We can do all sorts of interesting things. Okay, so it's really, really quite straightforward to do this. There's a package called dev tools that actually makes it even easier to work with. And 95% of the time, it does exactly the right thing, which just makes life easy. I kind of think is yeah. For some reason, I'm having this concern that half of these are gone. So I write these things in weird, maybe not. I put them in odd order too. Okay, one of the absolutely things. Oh yeah, I'll come to it later on. But just while we're here, just the purpose. It's easy to share, okay, with others. This is why it comes later on, but just it's a pain. It's an extra piece of work to write a package. Okay, if I've got 3 files with our code in it, it's an extra piece of work to put a package in. It takes 3 to 4 minutes. Okay, I don't have 3 to 4 minutes. Okay, no, but it actually saves 3 or 4 minutes later on, and it may take a little longer, but the first time or two are around. But here's one incentive I have for actually organizing your data in packages. There's one, we'll get to this later on when we're talking about writing packages, but just to set the tone. One of them is if you actually want to run this on another machine, so if you're on your laptop and you want to use a compute server, it's much easier to install a package than it is to actually make sure that you've transferred all the files and then you source each of the files in the right order and all that stuff. Yeah. But what's that? Even bigger, so it just makes your life easier and it saves you the 3 to 4 minutes. So if you're on a cluster with 10 nodes, then you actually have to share it across those nodes. And you're going to do an awful lot of silly, repetitious work. And then you actually have to make sure everything is kept in sync. So if you make a change on one machine, you've got to do it elsewhere. And it's just much easier to install a package directly from GitHub or whatever, or from a repository. But one of the biggest incentives I have is I have office hours, Carl has office hours, several other people have office hours. So sometimes I say, just send me your code. If you send me 2 R files attached in an email message and a data file and then an R script, I won't run it. Okay, it's just too much work because I have to detach it and put it in the right place and I source it in and it doesn't work and geez Louise. Whereas if you just say, oh, it's on GitHub. Okay, what's the name of the package and what's your login on GitHub? In one line, I will install that package and then I will actually run the script and go, I found your problem. Okay, because that's the hurdle for actually getting help from other people. When you actually make it easy for them to install, it's a wonderful thing to reduce by using packages. So that's my biggest incentive is other people will help you more if you make it easier for them to help you. And that is make it easy to install. Don't make it source in these files. And when you write a package, you tend to actually write code in a way that it refers to other functions in that package. It refers to data in that package. It refers to everything self-contained, which means when I download your script and it says C:users Carl, okay, and I go, well, I don't have a users Carl because I don't have a C drive either because I ain't on Windows. So I'm gonna have to change this and then, okay, time up. I'm not helping you. So it's a much saner arrangement for yourself and for others. And this is hopefully you should all be familiar with this. I'm expecting. Anyone not familiar with installed R packages? Has anyone seen this? Installing directly from a tar file that you download off the web or that you create locally, and that you actually still use installed R packages, but you specify that the repository is null. Okay, that way it doesn't go. If you say package and say repos, and you just say repos, it goes off. Okay, in this case, it will go off and try to download the package named package. I'm going to put in a real package name there. Okay, from CRAN or from your repository, whatever mirror you send it to. But if you want to say, no, it's a directory sitting right here, okay, we just say repos equals null. Have any of you used this before? Very handy, okay, if you're working locally. If you're just absorbing packages from CRAN, life is great, okay, but then you're always going to be, you're not going to have the latest and greatest, okay, because when somebody has a new release, so you can download it and you can actually sort of, you can git clone a repository, make some tweaks to it if you want, or do something to it and then install it locally. You can use installed R packages, but you have to specify that the repository is null. Otherwise, it goes off to the web and starts trying to find it on the CRAN mirrors and says no. And you can also install directly from an archive, a tar file. Okay. which is how we distribute source packages, okay? This is source package, okay? Life is fine. You can vectorize this. It takes care of all the dependencies, not if you say the repository is not, because there's no place to find the other dependencies, okay? So then it doesn't go off and try to find additional stuff and you're on your own. How many of you have used this, the tools? Okay, good. So this is another way of just going straight off to GitHub, and now you're basically getting, you have different branches. You can tell it which branch to get, which branch to install, and life is good. So now again, you're installing it directly from source. What's the problem with this?
Source could be changing.
Source could be changing. That's definitely a problem, but hey, that's what you signed up for. I'm going for the latest and greatest, okay? And hopefully, and this is a trick we'll talk about at the very end, which is hopefully it's a good practice. And again, good practices are for people without imagination. Okay, you want to just go and do whatever works for you. Okay, but it's a good idea to actually have where people are developing a package that you could install a stable package, not the one on-prem necessarily, but one with new features, but that it's stable, that it actually installs. There's nothing worse than actually making commits to your package that other people are using, and it literally just doesn't install. So it just has syntax errors all over the place. And now when people do this, it's broken. Now they don't know what to do. So it's good to actually be developing on a branch, and then when you're ready to actually say, you know, this is ready for the public to see, not necessarily to release a version of my package, but for people to actually be able to explore, then I'll merge it back in on the branch, on the master branch, so that people can still use this. But every time they use it, they're not going to actually go, well, this is a crapshoot, let's see whether it actually works or not. Okay, so this is good. How many of you have ever done this? Okay. Those of us who live on the command line, okay? So there's another thing which I'm glossing over entirely, okay, is the way most people do this is RStudio point click, and you select the ones you want and off you go, and you don't know what, you know, and that's fine. This is all wonderful. It makes life so much simpler. The reason, I'm assuming that that's all straightforward and easy to actually understand, so there's not a lot of point in talking about it. The other reason I like to talk about all the stuff we're going to talk about is because when things go wrong, you need to understand what's going on underneath it. And if you want to tweak things, it's good to actually understand. And it is really so simple and so much not rocket science. It's just kind of actually nice to know. Okay, so that's why I'm talking about this stuff. Okay, so basically, this is from the shell. This is from a terminal or from a shell command, and this is actually a useful thing. There's this R space CMD. The R command is a way of running arbitrary R commands. There's things like R command install, R command build, R command compile, R command check. Okay, all of those are related to packages, and you kind of want to actually know how these work. Again, when things go wrong, you really want to know, but often they're just actually more direct than pointing and clicking in RStudio when you're dealing with something slightly non-standard or non-trivial. But basically here, we're basically saying run the R command named install, and then we preface this R with the actual command, because that sets up the entire environment and knows exactly where to find absolutely everything relevant. And now basically, these two are the same as these two, but these are all working off of local directories, okay, or local tape archives, okay? Life is good, okay? Okay, so this is just a shell command. We'll come back and actually look at these, and these are useful to know. So many people look at me and say, what are you doing? Why aren't you using RStudio? I live in the shell. Many of us do. Okay, we're doing certain things because it's faster, because it's generic. It's exactly the same interface for everything. Your mileage may vary. These guys here, okay, and we'll get answering my question back here. What's funky about this? It was definitely that the code could be changing, but this guy, you're actually installing from source. When you install like here, from here, you are probably installing a binary version of a package. Okay, it's already been pre-packaged, it's been pre-built. If it's got C code or Fortran code or C++ code in it, you don't need a compiler because it's already been built, it's already been compiled. Whereas if you actually are installing from source here, okay, or off here, you're gonna need those tools. If it has compiled code, you need to compile it. The funky thing about this is if you're using binary packages are specific to each operating system. Okay, so you can't take a Mac binary and just use it on a Windows machine. So and CRAN builds all these things for us. Life is great, but you should be aware of that some things These are problematic. If everything's on CRAN, life is great. Not everything is on CRAN, and certainly not the greatest, the latest, the greatest versions are not always on CRAN. So sometimes you actually have to install from source. So it's kind of good to actually have those tools sorted out. On Windows, you just install R tools and so forth. Okay, so this is kind of a useful thing to know about, just because we'll come back to it. But there, and then the repos equals null is just a good idea. How many of you have set your repository? Okay, so most people just don't set their repository. So we have a whole lot of mirrors. We have whatever it is, I think it is now about 60, 70 mirrors lying around the country, around the world. Okay, so when you specify the repository, you're actually specifying which mirror to go to. By default, it'll go off to the one in Austria. Okay, or else it'll try to actually figure out where to go locally, depending. But you can actually set your repository to an HTTP address where it actually goes off and reads from it. One of the things we'll see later on, this is very useful when you've got all your code on the Git repository. Okay, say this doesn't handle binaries. So if you have if in your lab there's one person who's using a Windows box, okay, so somebody using a Windows box, they're special. Okay, and you have to deal with them carefully. Sometimes it's really nice to actually set up a Windows environment, build a binary, make it available, but it's not on CRAN. Well, then they can actually point at your repository and go, I'll show you how to create a repository that is just like CRAN, but just for your own private packages. You don't have to go through the scrutiny of getting a package on CRAN. Okay, it's all good, but you can, but basically you can mirror everything that we do on CRAN and globally. But you can, and then people can specify different repositories, and it's a good idea. Typically, I think oftentimes, depending on which version of R you're using, it'll just come up with a list of mirrors to choose from. How often do you do that? Once or every session? Do you pick a repository? Just once, because it stores your saying. But you can set that. Okay, so it's good to know that. So our studio is hiding a lot of stuff. I mean, you can set this in the options in R. You can programmatically specify the repository. Okay, if you just go back over to, I just go over to options and I look at the repos. There's my repository, and I've actually got 2 repositories in here, so I've actually searched them in order. So I look at the one in Berkeley, which may not be a good decision, by the way. Not all mirrors are made equal. Okay, some of them fall out of sync a little bit, and the CNR in Berkeley a couple of years ago fell out of sync. I can't remember. I don't know if that's a date now, but I tend to build from source, and it's not a big deal. So, but you can specify this in your options. You can specify the repository. You can also specify what type of package you want, what binary or source. I like source packages because I can build from source, and it makes my life happy. Okay, so I tend not to use binary packages because I'm weird. Okay, so anyway, that's happy there. Okay, so this is the question. Okay, and again, it's all over information. Yeah.
How does installing the source make a
Because when it doesn't work, I can fix it. Okay, because I always get the latest version that I want, and then I compile it to my machine. So there's some funky things about binaries that, you know, it's really funny. If you install a binary with C code for a Mac, it's potentially linked against different libraries. Okay, that I may or may not have on my machine exactly the same versions and all that sort of stuff. So things can go wrong. It tends not to, but it can go wrong. For simple packages with just R code, it's no problem. It doesn't matter because it's easy to install from source because there's no compilation going on. We just literally source the R code in and save it. Okay, for packages that have Fortran C or C++ code, it's just a little bit funky. And sometimes, so on my machine, and I was just doing this yesterday. I mean, I have so many different installations. I can't find the version of Python. I have a Python 3 installed. I can't find itself. Okay, and so I have all these different packages. I have many versions of the same library. Okay, like not an R package, but of C code. That's fundamental compiled code on my machines, and I actually switch between them. So for example, there's one package I have called RLLVM. LLVM is a big library for generating machine code. Okay, so it's compiling code. I need to test against 5 versions of LLVM, the development version and all the previous versions. So I literally just install my package. Yes, it works, and I switch to another version of LLVM and install my R package again.
and I have to be able to swap out different things. And likewise, I have all these different installations. So I'm kind of very weird. I know that I'm not saying it's a standard, but it's kind of handy to be able to actually do things from source. Okay. So does everyone know where an R package is installed? It's all written here, and how to control it. Okay, so when our studio again hides a lot of this from you. Again, I'm not trying to say this. I'm not trying to say it's a bad thing, or you have to worry about it. But when things don't go right, you have to know how things work, and it can be useful because it can end up helping debug stuff. But basically, first of all, we have this weird, horrible, leftover legacy nomenclature. To load a package into your R environment, you click on something, okay, in our studio. But by the way, one of the other reasons I'm talking about not pointing and clicking is sometimes if you log into our compute server upstairs, or if you log into AWS and stuff like that, you don't necessarily have our studio running on the machine that you're in. The command line is a really, really useful thing to be able to actually utilize it. It's always there. And you can programmatically do everything you do in our studio. So it's kind of very nice to actually be able to have portable code rather than manually actually having to be present. But pointing and clicking, you can load a package into R. But at the R command line, we use the word library ggplot2, okay, or whatever it is. That word library is a very, very unfortunate choice of word. Okay, it's actually loading a package, and what we refer to as a library is actually a directory which contains multiple installed packages. Okay, so a library is not a package; it is a container of packages. It's a very, very unfortunate choice of term. Okay, then we actually have a function called library. Okay, so that's one of the things. Okay, but basically, when you install R, all of the recommended packages like base stats4, okay, so for R part, they actually live in there. They live inside that version of R, in the installed version of R. They have a subdirectory in R. So you have the R executable. You have these R packages, okay, that come with R. When you get a different version of R, you get a different version of those packages because those guys have to be completely in sync. You cannot use a version of one of those recommended packages from version 2 of R with version 3 of R, okay? They have to be tied to that package, to that version of R. So R has its own recommended package, its own directory for the packages. So when you then go and install that package, depending on the permissions on your machine, you cannot write in there, and you should not be able to write it there. And it's a bad idea to be able to write in there to some extent. Because if you actually have this, because if you have R 3.3.1 installed, and you have installed thousands and thousands of packages in here, and there are 12,000 packages on CRAN, a couple of thousand packages elsewhere, so you can quite happily have a couple of thousand packages. When you then install 3.3.2, if they're all sitting underneath here, they're gone. You will not see them, okay, because they live in this. We like this. Those two should be binary compatible. This is a minor version. This is a patch release or update from here to here. We tend to make them binary compatible, so the same package will work, so you don't have to reinstall all 1,000 packages. But instead of having these under the R directory, under the R home directory, and then having to replicate them all over here, if we have a few of the recommended packages here, so these are the recommended packages, and likewise over here, if we have another set of the same recommended packages, but for this version of R. But if I were to be able to, in my home directory, the international symbol for home directory, okay? If in the home directory, I always have a directory called R packages. And that's a directory called R packages. I now have another one called R packages 2. Okay, 3 and 4 and so on. Okay. But what I'm going to do is I want to install everything into here. And then what I do is when I run R, I have it look in here first, and then in here. And then when I install this guy along, or we're still in system administrator, let's change this one to here. And I go, hey, I've lost all my packages. You haven't lost any of your packages here because Now, when we run this, we still look in here, and then we look over here. R automatically looks in here, or it looks in here, and it knows where it came. And then it looks over here first, based on the intelligence. Everyone familiar with this? So how do we specify this? How do we tell it where to look? I have our packages and our packages too. I had this because in the latest development version of R, we have binary and the same package. Two versions of R. I have 5 versions of R, and they all have to have slightly different versions of packages. Oh crap. Okay, so I have 2 different versions, and depending on which one I'm running, I say look in here or look in here. How do I specify where to look? R, well, there's almost no way to stop R looking inside its own bootstrapping directory. Okay? This is where base is, and base is how we actually, and then there's also tools, okay, and stats. This is how R starts, so R needs to know how to find itself, to literally bootstrap itself. So there's no way of getting around those. But how do we specify where to look? Okay, so there's a function in R called live paths. Okay, and if you call that function, okay, it starts with a dot, so it's hidden by default. If you call this function, it will tell you where it's looking. Okay, and if you call that function with an argument, it will actually change where it's looking. Okay, so if you just say .live paths, okay, it tells me I'm looking in 2 places, here and here. Okay, this is where R is installed. This is the actual build of R. That's its own internal bootstrapping. And this one here is my R packages. Okay, and I can just, and if I wanted to, I'm going to set it. So if I can actually do this, and all bad things will happen, which is .live paths of 2. Okay, so this will actually allow me this will allow me to set the paths to just be the set thing. Okay. Okay, and now if I, okay, now I can't find anything. So if I now load the XML package, it says, no, you can't. Okay, because it's gone. Okay, now if I want to, I could actually do this, live.loc equals our packages, and it says no problem. Okay, so this is just illustrating that. Okay, it will automatically look in here because I've set it up to be here. Now, for some unknown pathological reason, I told it not to look in there. I could have set I could have set R packages to, then I load the XML package. It will load from a totally different place. It will go through the search path. But here, there's another mechanism by which I could say, don't look in the usual places, please. I'm in charge. Look in here, in this totally different place. And now I can just basically load in different places. Yeah?
Does the order matter?
Yes.
That if it is there,
Definitely. What we do, we search in sequence. So it'll look for the XML package in here and find it. We're done. It's gone. We install that. If we're looking for the stats package, we look in here. We do not find the stats package. Then we'll look in here and we will find the stats package, and we'll keep going until it fails. Okay. But this actually allows me to install. For example, this allows me to actually override the packages that are built into the Bootstrap. Into R's own recommended package. I can actually go and change the stats package, have my own version, and R will not find it in its usual place, and we've overridden it. Okay, happy? So there's sequence. The order is vital here.
What's the process like if we don't currently have things organized like this? Is it a pain to try to get stuff moved over if you want to like make an R packages file in your home directory and you'd rather move it out of like lines and library frameworks?
No, you could just, for the most part, you can actually just move them.
Yeah.
Okay. And for the most part, that will work. Or alternatively, and this is actually, there's a variety of functions that you can actually, like, so there's this, install.packages, and is a function that you see. There's also a function called available packages and so forth. Okay, so this available packages is actually will go off to the mirror, the CRAN mirror, or CRAN itself, and ask
for a description of all the available packages and explain what they are to you. You know, you get a lot of metadata back. And then, of course, you can also very easily write, we can do it now if you want, which is we can list the files inside each of these and actually find out which packages are already installed. And so then what you can, and there are scripts and there are packages to do this thing. You can basically say, you can say list.files of .lib paths, okay? We'll just say number one, we can do both of them all, okay? This goes off and finds all the packages in my live paths. Okay, and we get back an answer, which is, these are the actual PKG, these are the package names. And what you can then do is you can actually just pass that straight over to here, and it will then just actually go and reinstall them all again from scratch. Now, that's not the same thing as just moving them.
Yeah.
For one, it's safer, okay? But secondly, well, it's a really handy way if you want to. If this goes from 3.3.4 to 3.4.0, and now you go, uh-oh, these are not binary compatible necessarily. What we often do is we just say, go tell me all the packages I have installed here, and then just go and forcibly install each of them all over again, please. And it will take care of getting all the dependencies right. So you'll give them alphabetically, and it will actually figure out, I need to do this one first, then that one, and so forth. So there's a little bit of meta programming here where you're basically saying, I'm going to call install the packages on not by giving it the names, but actually computing the names programmatically. Does that make sense?
Yeah.
The trouble with moving a package is that, as you'll see way later on here, sometimes we can be bad, we can be lazy, and sometimes we actually capture where the package was installed as part of the package so that we can refer to it. Now, there's always a way around that, but some people sometimes hard code stuff in like that, and so it's good to avoid that. But either way works. The move will work 95% of the time. Okay, happy? So what you can actually do is, so how many of you have a file called .r profile? So how many of you have a directory here where you keep all your packages? So how do you tell R to look there?
Is it in your .r?
You can specify, you can call .lib. So we know how to tell R to look in additional places using .lib paths. But how does it get called to do this? Well, we just type it. We just type .lib paths. This gets really old really quickly when every time you start R, you type .lib paths and tell it all sorts of things. So this, in your home directory, okay, again, international symbol for home, tilde, okay, tilde/dot, capital R profile is a file. You can have a text file which contains pure R code, and it will get run every time you run R, no matter where, whether it's RStudio or R. And in there, you can actually put this. You can put in these commands called live paths, and you can do all sorts of weird and wonderful things. Where you can sort of say, if it's Tuesday, use this directory. Or if I generate a random number greater than 1, use that directory, okay? Or more specifically, if I am in if my current working directory is project 2, then I want you to actually use this directory. But if I'm in project 3, I want you to use this directory, okay? Or as often is the case when you actually have a file shared system, you say, what is the machine I'm on? Am I on a Linux machine, or am I on a Windows machine, or on a Mac machine? So the same profile can actually conditionally decide what to do, and that can actually make your life easier too. Okay, so this is just pure R code. You can do whatever you want. If you want, you can send messages to yourself and say hi, welcome, and have a good day, and be productive, or whatever it is. There is another trick that we use. I don't set my live paths this way for where to search by. I don't know why I don't do it. This is pure R code. You can do much more here than you can the way I'm about to show you. But basically, another way to do it is to do this. Specify the shell environment variable, okay? If you're using a terminal or whatever it is, or It'll work no matter what you're doing. It'll inherit. You can specify the shell environment variable r_lives or r_lives_user, okay, to be a colon separated list of directories. And what live paths does is it reads that environment variable, splits them, and then sets them equal to that, sets live paths to that. Make sense? Everyone happy? So you can set it two different ways, through the shell or through R, okay, or both if you so desire, just to confuse yourself. Okay, and then you're basically installing into personal libraries. Okay, everyone understand why you might want these different libraries of packages? We actually have different versions and different binary compatibilities. Python has a nice mechanism too, these things called virtual environments. You basically go, we could install everything centrally, okay? But then somebody wants to install version 1.2 of the XML package, and somebody else wants version 1.3. Well, we'll use 1.3 because that's the superset, okay? That's the most recent. Hopefully they're backward compatible. Until they're not backward compatible, somebody says, I really want version 1.2. Then you actually need to say, I have two versions installed, but they're in different libraries, and I need to tell R to look in different places as to which one to find. Okay, with the virtual environments, we can basically install a bunch of packages for the purposes of one project. Well, this is our way of doing the same thing in R, where we just basically, for a particular project, we have our own little collection of packages that are specific to that. We also have, if you don't find it there, go find it in the central place or in it. And I just showed you where we have two directories here. We can have 5 directories. So if you don't find it in the most specific one, find it in the next specific one, the next most specific, and so forth. Okay, so you can actually manage a bunch of stuff this way. Okay.
Does everyone know about this? Because I suspect you guys all do, but this is one of the most common problems we see on the R help mailing list, which is I install the package and the function isn't there. Yes, that's because you installed the package. You didn't load the package. Okay, so they're perfectly sensible to say, well, come on. You know I wanted to install and load it, okay? And it does make perfect sense. But basically, there's a big difference. So there's a slight subtlety here, okay? The first thing is, when you install .packages or R command install, or, when you point and click, that's just actually going off, downloading the package, installing it, checking it installed, putting it into the appropriate directory, and going, yes, everything was successful. If you'd like to use it now, you better actually use the library function or the require function. But until then, the only way you can refer to anything in that package is using the double colon operator, because you have not actually put it in the search path. Everyone familiar with the double colon operator? Okay. No, so and there's a good reason why you're not familiar with it. That's good. Okay, the double colon operator. So let's go back over here. I think
Okay, so so if I look at the search path here, okay,
so this is the search path. This is how R looks for things. So we got multiple search paths. We've got the live path for the library paths. Okay. We search along that sequentially, looking for packages when we call library are required, okay? And one other case, but we'll get there later on. When we're looking for not libraries, but when we're looking for objects, okay, when we're looking for variable names, we look along the search path in our workspace, then in whatever package is next, and whatever package is next.
so if I look for stats, so if I look for a t.test, okay,
we look for t.test, we look along here, we find it in here, okay? And it tells us it's actually comes from package stats. How do I refer to,
let me think of a function, it's not there. Well, let me just do this, which is, let me just do this one. Can't think of one offhand. I'm going to use this. Okay, I'm going to use 3 colons here. Sorry, well, actually, let's just do this. Actually, let's just start all over again. Okay. Now, okay. Let's look at the search path. I started all over again.
there is no XML package here, yes? So if I then type
there's a function in the XML package called XML parse. It says, I cannot find it. I have searched through this search path and I cannot find this package. And that's because I have not loaded the package. Once I call library or require, it will put it onto the search path. And I can control where it goes on the search path because the order in which we search here is important. So if I wanted to go near the end, I can tell it where to go, which position. But at the moment, but if I don't want to load this package because it's going to conflict with too many things, I just don't want it to be in the search path, I can just do this with the 2 colons. Okay, so 2 colons says, here's the package, and okay, and then I want you to go in and find this symbol inside this package. This is actually a useful thing to actually do when you're writing R code. Okay, if for an R package or something like that, you can actually put this in and say, just in case there's any confusion, I want to tell you exactly which package to use. Okay, there's a very strong difference of opinion as to whether this is a good thing or a bad thing. Okay, but that's fine. Okay, okay. So now we see it there. Okay, so when I type double colon, it works. When I type XML parse, it says, have no idea what you're talking about. But now if I do the following, library XML, look at the search path. It is now on the search path. That means when I type XML parse, it will look here, and then get it. Everyone with me? So very straightforward. Now it works, okay? Yep.
When you use the double column to call a function, and if that function requires another function that is within the package, would that call it, or if there's a function that has the same name but is in your
Very good question. Okay, so what's going to happen here? Okay, so I call XML parse. Okay, so code tools. I'm not going to load code tools. I'm just going to actually use the find globals function in code tools because I don't want to actually add code tools to my search path. And I'm going to say, hey, show me all the functions that XML parse calls. Okay, so here I'm actually using the double colon to actually find what functions XML parse calls. Okay, and that's what we get. Okay, these are all these functions. So here are all the functions that XML parse called. So if I call XML, if I say XML double colon XML parse, here's the name of the file. Well, it needs to find check handler names, add doc finalizer, set XML error handler. It needs to find all of those things. But because the XML package, because the XML parse function, see it? It's actually in its own namespace. It's in the XML namespace. It doesn't look for those other functions that it's referring. It doesn't look for those extra functions that it calls along the search path. It looks for them in its own search path. Every package has its own little search path, defined by its namespace. So it looks along those guys, okay? And it looks inside itself first, so it finds them there. And then it looks along inside the other packages on which it depends or imports specifically. And then keeps going. And every package depends on base. Every package imports all the functionality from base, okay? And that's where we find the if function, okay? So it knows how to find the language.
So
Why is it a bad idea to which? To do the...
Because you said there is a more feelings about it.
So the reason is, and we'll get there, we'll talk a little bit more about this. This has been something that kind of a fun thing, more than all the stuff people provide and give this discussion to have. And some people say, if you write this in a package, so if I have a package called my package, and it uses some XML functionality, and it turns out it's an XML double colon, and some people think, well, that's already implicit in the import, okay? So my package will import the XML package, so it's clear that the XML parts comes from there, okay? Other people say, well, no, you're just adding more verbose descriptions of where it comes from, okay? But if you imagine if you did this everywhere, so you said base colon if, base double colon if, base double colon class. Now all of a sudden your code is a mess. Now, you know, so it becomes a wild pain. And technically, when we actually do this, So there's a stylistic thing. That's one of the big issues. And you don't need it. It's implicit. If by chance I actually change my imports, and we'll see this later on when you're writing the package, you say what packages you import. If I wanted to, there's the XML package that has an XML parse function, but suppose you went over to the XML2 package and it has a different version with the same name, you could just change that one line of the import to put it in first, to put the XML2 package first, and you wouldn't have to change all your code. Okay, so therefore it's kind of you're putting in redundancies that actually make the code more rigid, okay, or more constrained. So that's bad news. And technically, when we actually do this, just for fun, when you use this to call a function, the first thing we do is what we're actually doing here is this, and then we call the function. We first of all compute this to get a function back, and then we call it. Okay, so there is actually some computation going on in here. Okay, and in certain cases, some people think it can actually be expensive. It's that expensive. Okay, so it's really not a big deal. Okay, so it's not a huge issue altogether, but it does actually make the code a little bit more rigid. That's why some people. So it was kind of funny when one person sort of said, "Oh, I do that all the time." The other people sort of said, "You're nuts. This is terrible." It's like, really? This is our core having an email discussion. You go like, really? There's 17 or 19 of us, and we're fighting about this sort of nonsense. And like, clearly, there's no uniform agreement. Okay. Yeah. So that's that. And then also when you look at this. So there is for various historical reasons, there's a function called trim, okay, which just takes up white space on either end. There's lots of different versions. This is 20 years old. It didn't need to get exported. This, you cannot see this in the XML package. When you type ls on the XML package, you can't see it. It does not get listed as part of the exported functions. But the 3 colons, as opposed to 2 colons, says, I know it's there, give it to me. I don't care. Okay, so you can still put your hand in even where you're not supposed to and actually pull out things that you actually want. But the key thing, let's go back where I was. So this triple colon is, even if you put the search, even if you put the XML package on the search path or not, you need 3 colons to get an object that wasn't exported. Okay, that wasn't made intentionally available to end users. Okay, but if we go back to here, so if I detach number 2, okay, so the XML package is no longer there. So if I type XML parse, okay, there we go. And by the way, this is a good thing to do when you're finished with a package, detach it. Okay, throw it away. Or actually, a really good thing to do is don't ever load any packages through the search path. Okay, don't use the library or require functions. Okay, for scripts. Always refer to the ones you want with XML : XML parse. So A, it's clear, but they are never in the search path. So there's no way you could possibly conflict with it. Because if XML parse by some chance does define the if statement, or if the XML package does define the if function, you're going to get it if you call if. Okay, and that's very bad news. Okay, all the code inside the namespace, inside a package will get the right thing, but when you're just doing interactive commands, the bigger the search path, the slower it gets, and the more chance you're going to find something you didn't intend. Okay, but when I do this, I get an error, but if I just do this, that's fine. And what is actually happening here, and this matters, okay? When we call XML : XML parse, as opposed to library, this loads that package. When I call library, it attaches the package. And they're 2 very different things. When we call library, we load the package and we attach it. When we just refer to a function or something inside the package, we just load it. Well, we do not put it on the search path. Okay, it's much better not to put it on the search path, as okay, because it doesn't pollute the namespace or the search path. It doesn't have conflicts, but it will load the package, but not attach the package. And this actually matters when we start doing funky things when we write packages. Okay, is that clear? Yep.
So we need that attachment means to put something in the search path.
Yes. That's exactly what it means. Okay, and that's why when you want to get rid of a package, you detach it.
So you don't unlibrary it. Okay, it's kind of very, you know, and there is actually a function called attach that puts stuff into the search path. We just don't use it for packages. Okay, but it's we can.
And likewise, just to be clear, so if we take a look at the search, just for fun, search. If I say library of XML, remember I can specify lib.loc to actually say look in a different place. I know I've installed the version of XML, but I want to try this other version, this experimental version. I can specify where I want it to be, but I can also put in, if I take a look at the library function, okay, I have all of these things, and I can specify at what position in the search path to put it. So if I want to make sure that it doesn't come in at number 2, but it comes in number 10, so it doesn't actually, it gets searched later on, I can do something like library of XML pos equals 5, and then look at search, and now it comes in here, and I can get to control this. And sometimes it's very, very useful to do this. Okay, everyone happy? Where are we? Okay. So these are actually different things. Okay, good. Okay. Everyone happy? I don't think that's a good idea. I suspect. Let's just check. I wonder why that came in some weird way. Okay. Okay, so I'm sorry, this is all okay, everyone happy? So these are kind of weird things. You actually have an enormous amount of control that people don't actually utilize on how you manage R packages with installing in different places and doing different things, which can be very useful if you're doing some interesting, if you're doing something slightly non-standard. For most people, you install a package, but you don't install it again for another 2 years or until you install a new version of R, and hopefully somebody else installs it for you. Okay. Okay. There's a bunch of other things. It is actually, in my opinion, it is well worth looking at all of these extra arguments here. About the repositories and all this different stuff, to sort of see what you can actually do, and then to look at things like available packages and so forth, because you can actually do computations on the packages themselves. Okay. So forth. Would you like to say something?
Yeah, I'm just a little hung up on something you said. You talked about the sort of controversy between using this double colon operator and showing us, some of the flexibility of using the library. But at one point, I thought I heard you say, like, you should never use the library in your script. You should always use double colon operator. And I think you're just emphasizing the value, I think, but or do you mean that literally?
No, you shouldn't, no, I don't mean it. I don't mean that.
You're just emphasizing the value of avoiding conflicts.
This is really annoying. I mean, this really is annoying if you basically are doing things like, XML ggplot2 : John this, and ggplot2 : John, and ggplot2 : ggplot, and everything is prefixed by ggplot2, and you go, this is really annoying. Okay, and we're not going to change this very often like this time. If it's a one-off thing, though, I mean, if you're just, okay, but if you are actually loading we saw this yesterday, if you're using the plotly package, for example, okay, there's a conflict between plotly and ggplot2. Okay, and when you load the plotly package, it says I'm replacing this. So now you've got a conflict, and you may get the wrong one, but in that case, then you go in and say, no, let me tell you exactly which one I want, and now you're taking control of the order in which it's going to find, because you loaded the plotly library package after the ggplot2, so therefore now you have to say, look carefully, go beyond the first one you find. In that case, so you put it in here when you put it in rarely, okay? So when you're only referring to, so if you're doing something in the readr package, and there's a read.csv, okay, CSV package, okay, and you use this once, don't bother loading the library, because you're only asking for one function, okay? And so, and it's also, I think it's easier to read this. You're saying exactly where it comes from. The downside, but if there's 25 million references references to read R or ggplot, then it's just too many, because now it's just polluting the, the visual comprehension of the file. The problem with, but also the other problem of putting this in, likewise with a lot of ggplot2s, is now if there is a better version of read.csv, you have to actually go and change that line of code. So if you have 10 references to read.csv and you say, I've got another version that claims to be faster from IO tools, let me just slide one line of code in, just put it first in the search path, and now I don't have to change anything. So there's a trade-off, okay? But most people aren't doing that, so it's just like replacing one. Okay, so that's all I can. But there is this thing, if you are using a lot of packages, and you are constantly, and you're not using all the functions a lot of the time, but you're using 1 or 2 functions per package on a one-off basis, and you load up 25 packages, it gets slower and slower to search through them. There is one package, the other thing is kind of fun, I have a copy of all of CRAN on one of the machines, and I went through all 11,900 packages because I downloaded it myself. You can actually go through and see how many functions are in each. Oh crap! There's a couple of them that have ridiculous number of functions, and now they are searched cleverly, but they can actually slow things down the more you add to it. Okay, and it can make finding bugs a problem. Okay, but use common sense. Okay, but it is kind of interesting to actually look at other people's code and say I can't read that. I just can't. There's too many colons, or I don't know where it's coming from, because there's a comprehension. You're asking the user to understand. At the top, typically at the top of your script, you've got a bunch of library calls. So if they load in 7 libraries and then there's no reference to where the functions are coming from, you're asking them to either ignore it and just go with it, or you're asking them to actually mentally map this themselves, and that is beyond most people. And it should be. You have better things to do. So that's why putting the colon in is useful, but not if it's everywhere. Okay? Okay? Happy? Writing packages. How many of you have written a package? Okay, it's really easy. Okay? Okay, it's really, really, really easy. And I say, okay, when you're actually writing a package, let's say it's it's really good for yourself. You write a package, you install it, then you can just refer to it in all of your other code. But it's really useful to actually turn some of your utility functions into a package, so that you don't have to know where they are. You don't have to source that file in, and then remember that you have to source another file in, and sort of things like that. Okay. But one of the things, if you're writing it for yourself, it doesn't matter. Anything goes. You don't need documentation because all you do is you blame the author, and you look in the mirror and say, that's me, okay? Okay, and you try to remember. You've got a better chance of remembering what you wrote than anyone else has, of why you wrote it, okay? But anything goes, okay? And if you're not sharing it with anybody else, no problem. If you're sharing it with you on another machine, anything goes, okay? You decide how much effort to put in. However, there is and I don't mean creating an R package is trivial from existing R code. That's what I should have said. Writing a good R package is really, really hard. It's software engineering. How many of you have taken a class in software engineering? Okay, so we all talk to her. Okay. Very, very few. Software engineering is a whole different ballgame, because now you're actually trying to write code for other people to use when you're not there. Okay, if you're sitting there beside them, you just say, oh, no, don't do that, do this. Okay, but when you're not there, the code should actually do something sensible, and that means give a good error message. So actually writing robust code that doesn't go, sure, I'll take this. Half an hour later, it gets to a computation where the input is wrong, and you go, okay, that was a waste of half an hour. Okay, you were sitting there waiting. So we really kind of want the code to be robust to different inputs. You should be checking the class and type of absolutely all the inputs, as much as it matters, as early as possible to sort of say, we're not going any further here. There's no point in reading in this 10 gigabyte file and then saying, by the way, the second argument is complete garbage. Okay, you have to deal with, there's an amazing amount of times when your code will work perfectly when you call that function. And then when you call that function from another function as part of a bigger computation, there will be times when you pass it in an empty object. Like we have this problem, Matt might have this problem. Matt gave me code yesterday, again, we were working very quickly. Matt gave me code, I ran it, and I got an error, problem, I debug it, so there's a whole issue about debugging. I look at it, the inputs are empty.
and the functions don't actually know how to deal with empty vectors. This turned out to be annoying because instead of a logical vector, then it was an empty list. One I so we chase it back. Oh, that's annoying. Yeah, because we were reading data from different directories, one on his machine and one on my machine. So the problem is further up the chain, but now I have to debug it. Whereas it'd be nice to sort of say, if the error message came back and said this can't be right, you've got an empty list. I expected a logical vector with at least some elements. Okay, there's no names on this thing. That sort of stuff is really, really good. So just checking all the inputs is really, really important. Okay, and this again saves you problems later on. We do this later on. This is all good software engineering. You know, eat your vegetables, do good things, you know. But there's a time and a place, but it's a good thing. Provide meaningful error messages. You can actually give structured error messages. Best thing to do here is when you're writing a package for somebody else that other people will be using, think about how annoying it was when you used somebody else's package and got a ridiculous error message. So, you know, I shouldn't be that person. Okay, try to actually combine the inputs and actually paste them into the error message to say, this thing with these names, these three elements seem to be wrong. Okay, provide good documentation. We're talking about documentation. There's required documentation, which are actually help pages, but then there's also examples which are incredibly useful. And R can run examples interactively from the help pages, which is really useful. I imagine you've all seen this where you just type example of this function, or you click on something in RStudio, and it actually runs some code, self-contained code, and shows you a plot or shows you the output. Really helpful. But they're still only simple examples with almost no text. So we have these things called vignettes where you actually can now go beyond help pages. This is really, really useful. The other thing is, if you are going to actually write code for others to use, be very, very careful. Okay? It sounds like a great idea. For some unknown reason, people use your code and then they start sending you email. And they give you email saying, you know, I tried it on my data and it didn't work. Can you give me some advice? And most people are, I suspect all of you are nice enough that you'll try and you'll engage them in dialogue because you want people to use your code. All of a sudden, it's a huge time sink. Okay, and we have different ways with GitHub and issues, and it's all. This is one of the reasons why it's really useful to write it with another person. So you always assume the other person will answer the question. Okay, but the trick is people won't use your code if they don't get an answer. So the actual idea of getting traction of users is tricky. But if you can answer questions properly, that's great. But this is another problem. So we're having a discussion here on February 6th, which should be fun, which is actually the people talking about. If you take a look we have over 12,000 packages on the CRAN. How the heck do you find out which one to use, which has the functionality you want? Does anyone know the answer to that? I know, there is a very simple answer. Stack Overflow. Okay. Google, which brings you to Stack Overflow. When it's over, it's all done. Okay. Now there's a whole lot of human knowledge in Stack Overflow. That's the snag. And when a new package comes along, it takes a while for it to get absorbed. But the problem is there are an awful lot of packages where we just basically re-implement the same thing over and over again. Sometimes well, sometimes not so well. And sometimes later packages come along that actually give inferior implementations. It's very, very tricky. Try to avoid re-implementing. It saves time. It doesn't initially because you have to go find them, but it does save time. Okay? Make functions flexible. We can talk about that. These are all good things, but it's not about the actual structure of the R package. Okay? So there's this thing. It skipped over a whole load of slides. Okay, we'll come back and figure out why in a second. Okay? Okay. So I do not know what it managed to actually do here. So somewhere, I don't think it likes this. I don't think it likes this at all. Hang on a second. Nope. There's Markdown. I love Markdown. Okay, you have absolutely no chance of figuring out where it went wrong. Okay, so it's just like, okay, interpret and see what happens, and we do this thing. This is actually interesting. This is why I like to have low-level tools, because then now I can always get myself out of these problems. I'm probably missing a couple of quotes. That's probably where I'm doing it. That's probably it. There we go. 41 now. Okay, now I'm back. Okay, sorry about that. Okay, and this is where syntax highlighting actually helps, but it doesn't know what I was actually doing. Okay, so why write a package? Okay, again, okay, if you want to install it on multiple machines, all live, it's great, okay? This idea of actually being able to give it to me, I actually do answer questions about other people's code. Okay, I'm very happy to help people debug code. Okay, but only if it's easy for me to actually run it. And what you can actually do is send me a package, send me a link to a GitHub package and say, there it is. Install the package, and then in the package itself, there is an example in the help file, or there is a script in a particular directory, which we can talk about where it goes. Okay, source that file, and it will run, and then it will give you an error, and then I can debug it. Okay, it's a really, really helpful thing. Otherwise, if you just give me a collection of files and separate data that I have to put in the right place, it just doesn't work. This is a real problem. If you're writing packages, you actually can get some academic credit. It's actually useful. Okay, it's not, if it's a good package, it's great. If it's not, it's better than nothing. Okay, it's not, it doesn't get you the same as a paper, but actually some packages can actually, you can write a simple short paper to advertise a package. It does actually count as a publication in some regards, not necessarily as in the same prestigious journal as Nature or whatever it is, but it actually can be useful. But it is actually an increasingly useful currency of academia that people are beginning to understand. It is actually a useful thing. So this is good. Here is an R package. If you go into RStudio, you can click on a button that says make me a package, okay? And that is a wonderful thing to do. There's another package called Kitten that actually creates a package for you. There's a function in R that comes called package.skeleton, which will create a package for you. The snag about all of these things is that they're wonderful. They hide a lot of details. The snag about them is then they say, oh, now fill in the bits. And you go, which bits? And you go, yeah, the bits that I just created that I hid from you. And you go, okay, so you mean I need to know the bits? Okay, and these are the bits. So it will generate these, and it will fill these in via a template, but then you have to go in and make sure that it's correct or actually add in your own functionality. So these point and click and the packages are the functions to actually generate a template are really, really useful. Not okay, but you still have to actually know what's going on. These are the three things you typically need in a package. These two just have to exist, period. You have no choice. If it's a data package, you don't need any R code. And if it's just got a collection of R functions, all you need are these three things: a file, and a directory with some files. It's possible for it to have no R code. You can, if you'd like. This probably won't get you much academic credit if you actually have a package that has nothing in it. Okay. Probably not, although you never know. We count papers based on the title, so who knows? We might be able to. Okay. So that's fine. We also have these other directories here. These are directories, a man directory for manual/help pages. Tests. Good idea to have tests in here. Okay, not obligatory. Okay, and in fact, some of the tests will come out of the examples, so it's, you get them anyway. Okay, if you put them in. We have a data directory if you actually want to attach data with your package. And then we have this inst directory, and that's called inst for install. You can put any crap you like in there, anything, directory, phone books, whatever you want in there. That will get installed with the package. Okay. And anything else outside of inst will get installed only if it's one of these. But this inst is for auxiliary information that gets installed with the package itself. Everyone happy? This is all we have. So who knows how to create a file? Better know how to create a file. Okay, open your text editor, create a description file. Okay. I have created, if you actually, on the very front of my slides, if you go to DSI, github.com/DSI Davis, there's our workshop, our packages workshop repository. There's actually about 6 or 7 packages in here. Here's a package. Here is what I think about as being the world's smallest package. Okay, and if you'd like, I will do this in real time. Okay, I will actually start from scratch if you want to watch you type. Tend not to do this anyway. We take the description file. That's what it looks like. This is what's called a DCF file, a Debian control format, or also known as RFC, and 4 numbers, which I can never remember. Okay, nobody needs to know. It's got a name, the field name, colon, value. name, field, colon, value, okay? Okay, this is the minimum set. You can't put this on CRAN. It doesn't have enough fields here, but it's got pretty darn close. You can install this package straight on. If you want to create a package, the best thing to do is copy this one, okay? I can't remember what we're supposed to put in here, so I just copy one from an existing package. There's 12,000 packages on CRAN, just pick one and copy, okay? You have to have a package name, sorry. You can't have an anonymous package, okay? So you put in package and the name of the package. I call this rmin package, okay? It has to have a title. This goes in the documentation on the top of every page. It basically says this is a description of the high-level functionality of this package. Yeah, everyone happy? So this is, okay, this is not describing a function. This is describing the overall package, okay? You're supposed to have an author, okay? That can be just a name. You have to have a maintainer. This is a nothing thing that some people insist on, the CRAN people insist on. R now insists that you have, even if it's for your own purpose, you have to tell yourself that you are the maintainer of your own package, that no one else will see. So you should, and you need an email address, just in case you can't remember your email address later on. So you can send yourself an email. Okay, that's stupid. Okay, okay. So you have to have a maintainer. You put your name in, you put your email address with an angle bracket, with inside angle brackets. Okay. And you need a version. Okay. And we'll talk about versions. Okay, you have a version for each package, for each instance of the package. Okay, for each, so as things evolve, you should change the name, the version of the package. That's all you need. If, as some of you foreigners, I am a foreigner, but I don't have any funny characters in my name. Okay, if you have a funny character in your name, okay, you can tell it what the encoding is. Okay, remember you kind of, this is assuming ASCII characters, so you can actually, inside in here, you can actually specify the character encoding for this file and also for other files in the package. So you can say it's UTF-8 or it's Latin 1 or anything else. That's okay. So you can control, you have access to all of this stuff. You'll also see, if you look in here for the author and the maintainer, you'll also see actual R commands to actually create an author list, a call to an R function that actually collects up the first name, last name, whether it's the author, the creator, or the maintainer. So you can actually put it, so which actually provides more information. Okay, so that's a good thing. Everyone feel you could do this? So you can copy this, so you can get one like this. Now, I did this. I made 3 packages that are related to each other, and we'll see something, see something about it. When you copy packages like this, you tend to forget to actually change the name of the package. So that's a bad deal, okay? So you just make sure that you do actually, this is why actually having an empty template is a good idea, so you don't actually forget to update certain things, like leave the maintainer as being somebody else. So that's kind of not nice, okay? Or change, make sure the name of the package and the name of the directory in which you create the package can actually be different, okay? So, so that's not a big deal. And as I found out, I'd never actually done this. I'd never actually tried this. I created a package called A, okay? And R will not allow you have a package with a single character name, okay? Okay, there's only 26 of them, but okay, for this alphabet, okay. But so you actually have to give it a different. But I put this under the directory named A, but the package is called A package, and R can perfectly happily have a difference between the name of the directory and the name of the package. Okay, it used to, and it used to drive me nuts. Okay, so life is good here. Okay, so everyone happy? So let's go over here and let's go over to P. Okay. This is, remember we saw this R command install? So I can actually just go over here and I can say install rmin package. And it goes off and does its thing. It installs, it tells us where it's installing. Remember, I set this through my r_libs environment variable or through my .lib paths. Okay. The funky thing about this, by the way, is it may not use your lib paths if you set it in R profile. Remember I said I don't know why I set my package library paths in that R profile or set it in R libs. I know it will work for R libs when I'm installing packages. That's actually why I do it. Okay, so I tend to set it through r_libs. It's not clear whether when you run R command install whether R reads your .r profile or not. It uses what's called a vanilla startup.
I always have to remember what it actually does, whether it reads your R profile or not. So setting this, when it tells us where we're going to actually specify this. If I so desired, I could also do this. By the way, remember we said install.packages live.load equals, and I said install it somewhere else. Remember that? I can do the same thing on the command line. I can just basically say, let's put it into /temp, okay? And now it says, okay, and now it says, sure, I'll do that. It actually doesn't tell us where it's installing it, okay, because we've told it where. In the other case, it had to tell us where it was installing because it's implicit. So it says, I better show you this. But now we're basically saying, install it into here. Okay, so we get to control this at the command line. We can control it in install packages. If you're using DevTools and install GitHub, well, you got to read the help for that and see, do they use the same name as live.load for install.packages, or do you need to remember a different set of parameters, which would be all sorts of fun. Okay, so this is one of the reasons why it's nice to have a single one reference for all. Okay, so because I can't remember, it's too many different things doing all the same thing. Everyone happy? This actually works. Okay, so if I actually now do library of rmin package, okay, there it is. It actually loads. By the way, when you install this package, as we did here, it actually puts this line in here that says testing if install package can be loaded. Because it used to be the case where you could install it, but then when you actually went to load it, it couldn't. That would be very bad news. So it basically didn't install. It did all the important things, but except for fail the very last thing, which is can I load it? So this is actually important that it can actually be loaded. So we know this. Okay, so there's that, and now we do ls of 2, and that's okay, and now we actually have it. There is nothing in that package, apparently. ls of 2. So let's go and take a look at and see what's in that package. Okay, there is nothing. This is the world's minimal package. It has absolutely nothing in it. I actually have a namespace file in here because it will complain if I do not have a namespace file. This is the default namespace, okay? And the namespace is related to how does the code in my package find other functions that it calls from other packages, okay? Okay, so the namespace controls that. So how does it import functions from other packages? And also, what functions does it export to the user? This function here, you'll see this you will see either export and a parenthesis. This looks like our code. It's not quite our code, but it's close. So we will export a file, or we will export a pattern. This is the simplest thing. Export everything, absolutely everything. Dot star here is a regular expression that matches anything 0 or more times. So absolutely anything that's in the package will get exported. Okay, all those names will get exported. There's nothing in the package. It's really boring. Okay, if we actually take a look at this package, let's look at number C. This is a package called C package. Okay, there you go. Life's good. Here's the namespace. This one doesn't export by pattern. It's really useful if you have 1,000 things and they're all called A1, A2, A3, and 2,000, whatever it is. I don't want to type that out, although it's really not a big deal. I can programmatically generate it. Okay. Okay, so that's when we would use export pattern, because it's easier to specify the pattern to identify all the names of the things you want to export. Typically, though, and I urge you strongly to this, is to export only the things you want people to see. If you're writing a package, what we have is, when we write a package, we tend to do this. There's 3 functions that you want to use yourself or you want other people to use. These are the things that actually do the work. Then there's 25 million other functions, or maybe slightly less than that, okay? Which actually are helper functions for those 3 functions, okay? They're the ones you don't want people to see. But if you export everything, and then somebody calls library of your function and ls of that package, they'll see things that go on across multiple pages, and they will not see those 3 functions that you want them to actually use, okay? There's just too much noise. So what you want to do is you want to just export only those 3 functions and hide all the other ones. They're still in the package, they're just not visible. Is that clear? Make sense? So this is just basically just controlling what people can see. And this is what the export does. So what you do is you say export parenthesis foo comma foo1, comma foo2, comma foo3, bar, whatever it is, and you enumerate all the functions you want to have people see. Okay, that's all. Okay, if you want to, you can use this export pattern to do it by regular expression. Everyone happy? So if I install, let me just, okay, here's this, here actually is this. This is the other thing, okay? This is the world's stupidest function. Okay, I've gone for really, really minimal packages here so that illustrate just how trivial it is. You typically will start with some code that you source in. All I'm saying you have to do is create a new directory, put a description file in, put a namespace file in, start with export pattern paren, quote, dot star, quote, just like, I'll deal with you later. I'll start editing down what I want to export. Then create an R directory and move all your files that you had, all the pre-existing R code, move them all over into the R directory. That is a package. Okay, create the description file, create the minimal namespace file that exports everything using export pattern. Copy all the .r files over into the R directory. That's a package. Okay, doesn't have any documentation, but it will install. Okay, as long as your description file is reasonable, it has all the fields that we needed there. Okay, this just is a function that actually does it. How do you organize the functions? How do you organize the code in the R directory? I just said move them all over. How do you actually write code for? How do you write? Forget the R packages. How do you write code for R? Please. So you got a function that says run my simulation. Okay, and then that function so you have a function. And the way most people write it is you start off and you say, I need to read in the data, and then they add an extra argument. I need the name of the file from where the data, and then they say, okay, how many times do I run it? Oh, I'll make that a parameter. Sometimes they don't. They don't make that a parameter. They hard code it in, and then somebody says, I'd love to be able to run it a different number of times because at the moment when it's not working, I still run it 8 million times, and I'd like to run it twice to make it go faster so I can get to the end quicker. So, okay, so I'll add that as a parameter. Then they make this function about that big, and they make it a little bit big. Okay, so they have one function in one file, and it does everything known to mankind, okay? So it's a much better idea to make these functions much smaller. This is software engineering, and you start, so making those, you start from the top down, and you say, I need a function that does this. My function will call that, the answer back, then I need another function to do that. My function will call that. We'll take the results from those two and call it the third thing. And now I have a high level description. So I need functions to do each of those things. So I make these separate functions, yes? These are helper functions. Everyone with me? If I'm being vague, let me know. Where do you put those functions? Same file? Different file? Yes, could both. Different files, why? No, because you're going to source them in. So if you're doing this outside of a package, you're just going to source them in. So you got, okay? And if they're just functions, the order doesn't matter because you're not calling them when you source them. You're only calling them when you call one of the functions. So they'll already have been sourced. If you source one file and it actually starts doing computations that require a definition of another function, well then you better source that other function in first. Okay, just when you order. But so this is merely a stylistic thing. Do you put everything into one big file? And now you've got a huge big file. It's hard to figure out where each function is. Or do you put everything in their own file? Each function in its own file. In which case, it's a good idea to put if you're going to do that, every function should probably go into a file with the name of the function as the name of the file, so it's easy to actually navigate between them. But now you've got 8 million files open, and you have to remember. But that's a useful thing. There are also actually very cool little tools for different editors, like the file, things like tags files, where it can read your code and figure out where all the functions are defined, and it has an index of these, so you can jump directly to a function definition. So your text editor will do this for you. You don't need to know where they are. It will know where they are for you, and you can navigate this. And an intermediate thing, so you have one file for each function, or you have all functions in one file. There's clearly an intermediate place where you actually put in all the functions that are related to one concept in one file, and then move on to the next concept with a separate file. I tend to do that. Okay, but you know, get a style. If you're working with other people on this, don't have two styles. Okay, it's very complicated when you're actually switching between context. But it's worthwhile thinking like having separate files for separate functions is actually not a bad idea. But whatever makes it simpler. But one of the things you really want to do is actually make those functions really small. The bigger the function, the worse it is. There's a couple of functions in R which are like 1,000 lines long. No one can figure out what's going on inside them. Okay, they're just too long. You really want small functions. Okay, okay. So you take your R code. So literally, when you know, typically what most people will do, actually, is what you will end up doing is you will start writing some code, and you'll go, I should write a package. But you've already got the code, so now you just move it into an R directory, create the description file, create the namespace. If you are very good, what you will do is you will wake up in the morning and say, I'm going to write a package. And you will start with an empty directory, okay, and you will create your description, and you'll think about what should the package be called, how should I describe it, and all that sort of stuff. And you'll create the namespace file with the default, and then you'll start with an empty R directory, and you'll start writing the package out, and you'll start writing code from scratch. Either one works. You move the code in, pre-existing code in, or you start from scratch. Either one works. Okay, it's not a big deal. Everyone happy? Everyone believe you can write a package like mine? Yep.
Just maybe a sort of light question, but we're doing this little thought experiment where you just have a bunch of functions. We're not writing a package. But
Yes.
some of the functions rely on the other functions, and you're using this term, you better make sure functions that are going to be called by other functions are sourced.
Yeah,
in first. And I'm thinking, oh, is that I write library, load this package, but we're not talking about a package. So what do you mean by those functions must be sourced into the other?
So this is why we like packages, because we just don't have to deal with any of this. I don't even have to discuss this with you. Okay, if we're using a package. So what we're talking about now is the case of where you don't have a package, where you have, because you thought this is going to be easy. My PI asked me, or my advisor asked me to do this, so I wrote a function. Okay, and then I wrote another function that I needed, because I know my function is supposed to be small. Okay, and then I remembered that I had another function from another project, and that was in another file. So now I've got 3 files. Okay, and now I have to sort them all in. And one of them's over here, and one of them's in this directory, and the other one's in a subdirectory underneath here, okay? So now I have to remember where they all are. So I will have to source those files. Okay, literally I will have to call source this file, source that file, and source this other file. Okay, and then I'm ready to go. Then I've basically got everything loaded into R, into memory, and I can just call it, no problem whatsoever. Okay, the problem is that you have to remember where all those files were. Now, if they're all in the same directory, that's no problem. Okay, then I just say list.files of this directory, and then I do an sapply over those file names and call it source. Okay, no big deal. The snag is, again, if you send them to me, I have to detach them from. Whereas if they're all sitting on GitHub, I can clone the GitHub, and I can do the source, the sapply list.files source. But I don't want to write that. I just want to go install directly from GitHub as a package, and I can look at the help files if there's help files. But I also, in the examples on the help file, or in a script that comes in a script over here, I can actually run your script to that it doesn't define the functions, but uses the functions. This is now a self-contained unit that I can install, and I don't have to worry about the individual files as part of the package. Whereas that's the problem with the sourcing, is that I actually have to manually source. You have to manually source. I have to manually source. Each time I use your code, I have to manually source within and do some gymnastics to understand where all this is and make sure it's correct. And then there's a really annoying thing is for some of you, and this is when you start writing really good R packages, you start using S3 and S4 classes, okay? Because now you're actually getting into object-oriented programming and extensibility. And now the order in which you load those files actually may matter. So you can't just source them alphabetically, but you actually may have to source them in a particular order. And now I have to know what that order is. You know it, but you're asking me for some help. I don't know it. So you put it in your email, and now every time I do it, I have to go back and find your email and remember what it is. So the package will actually help avoid all of this. And I'd like to think it actually saves time rather than actually loses time. So that's the idea. Does that make sense? Good. Okay, and that's why we do it. That's why I mean it just seems like a lot more work, but it is actually not. Okay, so that's the description file. There's all these fields. There's all these other things. We haven't got to this depends, imports, and suggests, which is about to. This collate business here is another field where you can actually list all the files in your R directory, but you can specify the order just in case the order does matter. So okay, otherwise it'll sort them alphabetically. How does it get sorted alphabetically? R will look at it'll call list.files and it will source your files alphabetically for the package. R is hiding all the sourcing for you. Is that always guaranteed to be in the same order? Depends on what locale you're in. So it depends essentially on what alphabet you're using. So you may have a package that works fine on your machine, but then somebody halfway around the world in a different alphabet will actually get a different ordering and the thing will collapse. Okay, so that is something that sometimes we actually have to specify the order in which this matters. Typically, 99% of the time we don't have to worry about it, okay? I skipped the description thing. We had a title, you need a title. You don't need a description, but it's a good idea. The description is a paragraph that describes in more detail than the title what the package actually does. Okay. So there's all these different things. By the way, there's two places to read about this. Okay, the definitive guide to this is a thing called the Writing R Extensions Manual. When you're writing a package, that is the Bible. Some people say it's not entirely clear. Okay, it is if you know the answer. Okay, okay, perfect. Okay, there's also a package. I don't know. There's a book, a nice short book, which gives us. I'm trying to actually cover some stuff that's not in the book here, which is there's a book by Hattie Wickham called R Packages. Okay, it's a short book and it just brings you through all the common stuff, and that gets you going pretty quickly. Okay, so you can always refer to these. The Writing R Extensions Manual is they'll say it's a place to go to for all the extra functionality and stuff. When you have a version number, this is the way we like to do it. You can make any version number you like. They should probably go. They should go up. Okay, if you want, they probably should be positive numbers. Nothing prohibits you from making them negative numbers. Okay, but it's kind of stupid. Okay, but basically, we tend to use the same system for packages as we do for R and other pieces of software. This is the major number. There's a dash, then there's a minor number, and then there's a dot, and then there's a patch number. What do we mean by patch? You write a package and you make it available for people. Okay, you don't need a version number if it's only for your own purposes. Okay, you know what's changing and what's not. But if you want other people to actually know what's going on, you don't have a patch number. Basically, what happens is you write a function, you write a package that has a collection of functions, and you find a bug in it. A typo in a parameter name that doesn't get used or something, you just do something stupid, very simple. Somebody points this out and you find it. You make a change to that function. It now is better, it's improved. So you increase the patch number from 2 to 3. Okay? Why? Because when somebody else comes along and looks, they see it's changed. It's actually different. When I say install packages, it will actually look and say, you have version 2. You have version 2.2-34.2, but there's a 2-34.3. So we will go and get that. If it's saying 2-34.2, there's no point in installing. But yet, in fact, actually, there's a change to it. We won't see that. So we increase the patch number. We change this in the description file, and then we actually distribute that. Okay? Everyone happy? If you actually go along and add more parameters to a function, or you make it do something slightly better, you change them at the minor number. Okay? Again, this is all convention, but it's a good convention because people understand it. So if you're not actually, okay, so if you add a little bit more functionality, that's good. But if you make it huge, if it goes from doing one thing to doing 10 million things and solving a much harder problem and all that sort of stuff, that's a major change. Then you change the first time. But if you're just adding a little bit of functionality, it isn't just bug fixes. The patch is for bug fixes. This is for actual added functionality, adding more parameters to a function so it's more flexible, adding 1 or 2 more functions. But okay, that's the minor number, so you update the 34 to 35 and so forth. Okay, we typically start off at 0-1.0, and then we update the patch number because we always got it wrong, and so forth. We keep chugging along.
After a certain point in time that you've actually added enough functionality to actually change the major number, or you basically say, you know, all your code that used to work, I've changed the code in my package, it won't work anymore. I've changed at least one function so it's backward incompatible. Okay, that's when you change the major version and say, these two are not the same packages anymore. Okay, this is essentially a backward incompatible version. Okay, so we have two reasons to actually change the major number. There's a significant accumulation, or alternatively, we want to write another paper on the same package. Okay, which it's the same thing. It's like it's changing the title on paper, just permuting words. Okay, but basically we're sort of saying it's got a critical mass of new functionality, or it's backward incompatible.
Okay, that's the logic. This is a very useful thing to do. Again, what's actually happening with install.package and stuff is we're actually comparing versions, and we're choosing to install stuff based on different versions. So if you're not changing the version number, nobody knows, and you're not getting the right functionality. And when we actually install packages, we're actually able to say, we need this version at least, because that's where it actually has certain functionality. So it's very, very useful. Okay, so we put the R code, we put the R code in, and life is good. All the code will be sourced at installation time. This is important. The code is not getting run in the package when the package is loaded or attached. It's getting run. It's actually getting evaluated when the package is being installed. That actually may happen when you download a binary package. That code is run on a totally different machine. Okay, so any computations in it. Nearly always what's happening is we're just saying f equals a function, and that's all that's getting evaluated, so it's just defining functions, and that's no problem. Okay, but if you're actually doing any computations that are used in subsequent computations, not inside functions that haven't been called, but if you have a line of code that says x equals 1 to 10, and then you loop over x inside your package, that's probably wrong, but it's getting done at installation time, not when it gets attached or loaded. Okay, and we'll come back to this little guy called this dot on attach and dot on load. Okay, we got the namespace. These are the guys you actually want. Ticks you let go from markdown. Okay, you have export pattern, and here the export pattern should be a star here. Markdown doesn't like me. Okay, and likewise, you can export by only the ones that start with a lowercase letter here is a pattern. Okay, so this is all very, very, very straightforward. And as it says below, or explicitly export, here's the name of the function, here's another name of the function. We just comma separate these guys out, okay? Leave these guys, we'll come back to this. Here is, this is the bit I kind of wanted to say. This package C, see this? This package C, it is what it is, okay? Let's take a look at the package B, in B, okay? Sorry, I don't want to do that. I actually want to look at this one. I want to look at this package in A, okay? What's different about this package? I know because I wrote it. Okay, and also there's one imports. It's the imports, okay? That's the only thing I've added here, okay? So this is all very straightforward and simple, okay? Again, this is why packages are really, really boring, okay? But people think they're more complicated than they are. They're actually really, really simple. I have two packages B and C, and they provide two functions. Each one provides one function. If you take a look, if we go back over to B, let's look at B over here. Let's look at the namespace. It exports foo. And if you actually look at C, it exports foo. I've done this very, very, very intentionally, okay? But they only export those, okay? This is kind of wacky. This is an intentionally simple example. This guy over here, okay? So let's take a look at here. This is what else we put in the namespace file. We repeat ourselves, which is kind of annoying, okay? But it's not a big deal. In the description for the package, a package, we said this package imports these two other packages, okay? It doesn't, now we can have depends, we can have suggests, and we can have imports, okay? We like imports. The more you put in imports, the better. If you put it as a dependency, as depends on these other packages, they will automatically get added to the search path. We said try to keep stuff out of the search path.
Okay, there are occasionally reasons for doing it, but very rare. So we typically do imports. So we actually enumerate the packages that this package, a package, imports these two packages. And then we come along and we say, okay, it exports this pattern in the namespace for A, or a package. We also say it imports this package and it imports that package. So I have a question for you. Which foo will it find? Both B and C, it both export foo. If B exports foo and C exports bar, okay, two separate functions, okay, each of them has lots of functions. That's great. My package, A package can now refer to any function inside B and any function inside C, and I don't need to say B colon that and C colon that, double colon that. I can just refer to them directly. And it will not look on the search path for other functions. So there'll be no conflict with the search path. It's basically saying, when I look at this, A package will look in B for any functions that it doesn't find inside A package. It will look in B package and look in C package and look in the base package, but it will not look anywhere else. It will not look on the search path. That's the beauty of the namespaces. Okay, so there's no chance that your code will behave differently when different people have different packages attached to the search path. Okay, this is sane. Otherwise, literally, the behavior of the package would change depending on who had what package attached in the search path. This is much more sane, and that's why we actually like this. But both of these export foo. So which one will it use?
C. C happens later.
I should have used two things that don't sound the same.
B and C sound well. So one of the things we can actually do is, and we go over here, and again, I've made all this code available. If you want to just play with it, you can actually let's install B. There we go. Let's install C, and let's install A.
In the installation, this is actually a good thing. It actually says I am replacing the previous import of C with B. Okay, so now the next question is, what caused that?
Well, I wonder if I switch these two, because remember, if I go back to if I look at the description in here, I have them in a different order. Okay, so which order does it actually? Which order does it actually matters?
Okay, it's the actual call of the namespace here. So we just basically say, in the description file, we're just saying, oh, here's a collection. I don't really care what order. But we actually have to repeat them over here. That import, we actually have to import over here.
And that actually matters what the order is. This is a pathological case, hopefully.
Okay, but it kind of basically says, this illustrates that we have to import.
And sometimes it's very useful to say, to be able to say, I'm going to import from C package. I'm just going to import foo, okay? So if you don't want to import all of the package, but just a couple of functions, this is another good thing to do, okay? Import from, and we now have, this call to import says import everything it exports. And this one over here says import just a few things, which is much cleaner if you know what you want, okay? But obviously if you're importing all but one of the functions, just import the whole thing, okay? Everyone happy? So what else do we actually need to do for a package? One other thing, and we can go in different order here, okay? But so this is I'm going to throw this out. How many of you know about S3 classes? Good. How many of you know about S4 classes? Even fewer, okay? If you need to use S3 or S4 classes, just be aware that you have to actually do something. When you're exporting them, you have to do something slightly different. You have to declare an S3 method as being, here's the function and here's the class. Okay, and when you're doing S4 thing, you have to import, often you have to import the generic function and then export the method. Okay, so you export methods and you export the generic again. It's kind of slightly, it can bite you. If you don't worry about it. Okay, just come talk to me if you have a problem. Okay, okay, so we can install different things. Life's good. Documentation. Okay, you don't need documentation. Yeah, you do, because you can't remember what the function did when you go to use it a week from now. Okay, you can't remember what that argument was supposed to be, so we actually want to write There's two ways to write documentation. Okay, at least two. There's a couple of others. Okay, there's two types of documentation, as I mentioned. Help pages, which you need. If you want to put this out for other people to use, if you want to go on CRAN, you need help pages. The things that go in the man directory, the manual directory. Okay, vignettes are really useful. The help pages are really, how many of you have read any of our help pages and said, wow, these are so helpful? So the trouble with the help pages is they're actually literally their reference pages. They basically say, they have a section that describes a description, okay, a description field, which can be very long or it can be often very short because that's just human nature. But but they tend to be more reference material. The vignettes, as I say, are more, hey, let me lead you through how you would actually use this in an actual use case or case study. They're very useful to write. You can write them in all sorts of interesting ways. Okay, ultimately they go out through LaTeX and stuff like that. Or Pandoc at this point. Okay, so there's various different things, but they can be dynamic documents and so forth. But basically, you need to have documentation for functions, data objects if you have any data objects inside the package R code. Any data sets, these live in the data directory. Okay, and then you also have to document methods and classes. Okay, if you want. There's two approaches to documenting. They all end up with only one approach because there's only one approach in R. Okay, and that is that you actually have to write. Okay, that if you look at this is what you actually have to write. Okay, at the end of the day, your package needs a file like this for every function. Not quite every function, okay? This is from the ggplot2. Just pick any package you want and you'll find these RD files. This is RD for R documentation files. They look like this. This one is generated by a thing called roxygen2. It's programmatically generated. It's a good thing, it's a bad thing, okay? Okay? In theory, it's a very good thing, okay? But that's fine. But ultimately, but you can write it like this directly if you want, okay? An RD file has this. Now, it's really annoying if you actually have to write this. It's simple though. It's like the template for the description of the namespace file, but just templates and you fill them in. There is a function in R that will generate this for you for each file, and then you just fill it in, okay? Pick your poison as to which one is easier. That both have one thing makes one easy, the other one makes the other easy. Okay, so they're big. But basically, this actually documents 3 functions. These are the functions. This is an alias for these 3 functions. Okay, and somebody will generate this for you. They have a usage section. This looks like, for those of you who know, this looks like LaTeX. Okay, and it's basically LaTeX. Okay, with very simple and minimal form of LaTeX. Okay, but you have these fields, just like these description files had fields. We have fields. Okay, that you have to fill in. These get generated for you. If you actually take a look from our Oxygen, okay, ggplot, what was I looking at? It was Jom, AB line. Here is where this code came from. This is generated from our Oxygen. This is the actual R code in the R directory. And what's happened is you have this the comment character followed immediately by a tick, okay, a single quote, and that says this is part of the documentation. And then a program comes in and actually rips out all this documentation and turns it into one of those RD files. So in theory, this is a really good thing, okay, because now the logic goes is because the code is so close to the documentation, when you change the code, of course you will change the documentation, okay? Okay, you won't, okay? But you're more likely to. Okay, so it's an interesting trade-off here. Also, notice, by the way, you're kind of writing in this. You're saying this is a section whose title is aesthetics. There's no section for this. This actually goes in the description. So it's kind of, you have to. It's like Markdown. You have to kind of just know what it does, and then just pray to God that you have made no mistakes, and that the RD file, which nobody looks at the RD file, we process the RD file. And you just hope that it all comes out clean. And if you're missing if you're missing a bracket here, think about how many steps this goes through. Okay? If you look up here, I can't remember if it's here. It's not here. It's not here. Notice that the @ sign here, for example.
The @ sign is a very important character in our Oxygen 2. Okay, it says this is, oh, I want you to include the contents from this file.
Down here, I want you to actually say, down here, we're going to discuss the see also section. You'll see in the RD file, there's a see also section. So
This content goes into the see also section.
very simple in terms, which is great. What do we use the @ sign for in other places?
Email.
Email. And it can get confused if you put an @ sign in here, in the middle of an email. So you put 2 @ signs in. Oh God, shoot me now.
And there's just, I mean, this isn't the deficiency of our Oxygen 2. It's just any language that does this. It's the shell has the same thing. Oh, you need to escape that. R's regular expressions. Oh, you want a slash in there? Put 2 in there. Oh no, put 4 in there. Okay, just put enough in there and just keep going.
Okay, it's just really, really annoying.
But it's irritating when you write the RD files and when our command install or install what packages work, it actually processes these RD files and says there's a mistake. Go away. Okay? And you have to go find out where the missing curly brace is. But now there's an extra layer where it actually gets taken here, generates an intermediate file and moves on and so forth.
So it's kind of curious. But in theory, this is actually a much more efficient way of writing the documentation. I am about to do an experiment. I started an experiment on Wednesday night and I didn't get a chance to finish it. 43% of packages on CRAN use our Oxygen 2. Okay, so not over 50%, but very close. And I suspect it's rising. And I have a hypothesis, I'm going to test, that the documentation is shorter. Okay, because it's a pain to write the documentation in here. Okay, because it's in comments and it just doesn't flow as well because it's not. Okay, it's all in the text editor. We can fix this with the text editor, but I'm going to find out if the actual documentation looks qualitatively different for our Oxygen.
But notice, by the way, you are using LaTeX, so you still have to know this stuff. So you're now mixing 2 languages, so it's an interesting thing. But this is a thing essentially called literate programming. Donald Knuth sort of came up with it. I've used it for years and years and years and years. I've written lots of stuff. If you look at the R byte compiler, it's written in not this format. It's written as a book. Okay, and we just take the code out and it makes it into a package. Okay, it's really nice. But the trouble is we don't tend to go back and actually edit this, but
you got a better chance. But there's another way of doing this. Okay, let me go over here and load up the C package. Okay. Didn't I? No. Is it called C package? There we go. Okay. Let's take a look at what's in the C package. It's the function foo. Not an exciting function at all. Okay. But if I just do this, here's another way of doing this. And I think our Oxygen 2 is really nice and has lots of good things. Choose both or experiment with both. If I want to, I can just do this. Prompt a foo. And it says no problem. Okay. And okay, if I go down here to foo, where am I? Over here, foo.rd, it has actually constructed the RD file for me. Okay, it put in the usage section. It would actually expand this all, have all the parameters and their default values. And all your job here is, this is a particularly boring one. So let's just do something slightly more interesting, which is f equals function of x, y equals 1. Z equals x plus y plus read.csv. Okay, of bar. Okay, ridiculous function. Okay, and now if I prompt of f here, okay, and I look at this guy, it's actually put in the usage. You don't change this. Okay, if you change the function, you got to change this. Whereas the Oxygen stuff is much nicer because you'll regenerate it from scratch. Okay, so it'll always be up to date, as long assuming that you keep your documentation the same. But you see, it's enumerated the actual parameters here, and then you just go fill them in. It's put in all these percentages. These are comments in LaTeX, so they're comments in R. So you just go in and you edit this, and you just fill this in. It's really, really irritating, okay, because you tend to do it at the end of writing the package, and you have to do 15 of them or 25 of them all at the same time. You get really bored, stupid. and you end up cutting and pasting a lot of the same text over and over and over again, and the documentation gets significantly worse and worse and worse and worse because you're not even trying. Okay, everyone with me? But it's pretty straightforward. If you want to actually say, oh, look, this is F, but I actually want to document G, H, and I at the same time, you would just put in an alias for F, H, G, F, G, H, and I, okay? And you go in and you copy the usage over here, and you just enumerate these the parameters and so forth. As you go down here, life is good. You fill in the details. Rarely, sometimes you just don't have any details. You're not explaining how it works. You go in and you explain the value. So say a data frame is returned, a data frame with R columns, with R rows where R is blah, 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 blah. And off you go and you start documenting. Start describing who's the author, it's me, or not. You can leave all these things out. You tend to just ignore the note, put the C also in. So it's very similar. R Oxygen 2 just maps to this format. It has no real flexibility in actually, like, you have to end up with one of these. And then and then we also put in things like this. You should actually take a look at, okay, so we say link to the function foo over here. So this is just this will put in a hyperlink between the two, so you can jump around, and that's fine. And then this is the piece of magic that is really, really useful. Okay, you go in and it's kind of ridiculous that you actually go in and take out the template, but what you do is you put in code here that actually runs. So these are all the examples. When you say example in R, it just runs this code, okay? And you can put in anything you want here, but this is really, really useful. These are the tests in your packages. These are the first round of tests. So these should run. They should try to illustrate different aspects of this function, and you just go ahead and write code that actually does this, okay? And there are times, because you can actually do things like this, where you can basically say if.platform. So, you go in and you sort of say, okay, F gets 1 and 2, okay, and life is fine, okay, and you can go in and start showing different things, all sorts of good things. But then you can also do this, where you basically, whatever it is, I think, let's actually just take a look, .platform. What you actually do is you go back and look and see, hey, let's look at the OS type. If the OS type does not equal Windows, because we always avoid things on Windows, okay, so you can actually put in, this is a regular R code that says, don't run this code under these circumstances, or only run it under this circumstance, okay? So you can put in conditional code here. If these data are available to me, I'll use it, okay? If not, I won't run that code. And then what you can also do is, this one's going to take 6 hours to run, so you better not run it as an example. Nobody wants to say example and then have their machine just stop for 6 hours before the prompt comes back. So what you can say is, here's how I really run this code, but let me put it inside a don't run this code. Okay, everyone happy? That's the documentation for, that is all there is to documentation. It is just the world's most boring thing. If you take a look at the Writing R extensions manual, it tells you how you can actually, these extra things that you can do, the link command, the code command, the /URL command, also there's itemized things for enumerated lists and stuff. If you're familiar with LaTeX, it's LaTeX. Okay, it's but a very minimal form of it. But it's a very, very primitive documentation mechanism that kind of works. R Oxygen 2 has got some nice characteristics to it. But the key thing is that you can share the same description of a parameter across multiple functions, and it basically repeats it for you without a piece of saying, see this function. So it kind of makes it a more complete documentation. But as I say, there's an extra piece of the pipeline which can be very frustrating if it doesn't work and you're missing a like a curly brace or something. That's fine. So here's another question I have for you. Okay. So there's this other thing, which is the keywords and concepts. Okay. All of these things, that's the other thing I seem to have found is that the R Oxygen people don't use keywords. We like keywords because we can actually then search for them. Okay, we can search the entire text, but we like keywords to group things and concepts. And people tend not to use this. I think there's nothing. It's not a limitation of R Oxygen. It's the way it's been used. But inside, you can look this up on the web. But with every version of R, there's a file called capital keywords. These are the only keywords you're allowed to use to actually put something to actually identify what category of documentation this is for, because that restricts the. You can also use a thing called /concept, which is a free-form version. So but you have to look up the keywords and say these are the actual ones. Things like high-level plotting. This is for modeling and so forth. Okay, so we have all these different things.
When a package is loaded, remember not attached, but loaded, and that could happen. When can a package be loaded and not attached? It's attached when you call library or require. When can it be loaded?
Source it.
No, you never source a package. Never source a package. You only source a file. Okay? So when can a package be loaded but not attached?
Did you say if you use the double colon?
If I say package : anything in there, okay, then it gets loaded. If I say help on the package, it'll get loaded. Okay? There's one other time it'll get loaded that we saw. Exactly. When it's imported, it'll get loaded. It's not the same thing. It doesn't go on the search path, but it's loaded because some other package depended on it through an import. So it just gets sucked into memory and it's there. And if somebody then says library of that package, it's the same package and it's not a different copy of it or anything of it. It'll then just go on the search path. And when you detach it, it'll go off the search path but still be loaded because another package still has imported it. Okay? Everything gets handled. But so there's a difference between the loading and the attaching, and the loading is implicit, and the attaching is very explicit when the user says library of this thing. But it can be very, very useful at times. You'll see this occasionally. So some people do this in their package that they say when you attach the packet, or when you load the package, they'll come up and they'll write stuff out to the console. The R console will say, "Hi, you just loaded this version of this package," and it goes through, and we don't like this very much. Okay, we tend to tell people to stop this. Okay, if you don't want that, you can actually, there's a thing called suppress startup package message. Okay, that says shut up. Okay, okay, it's kind of annoying, but it can be very, 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 very useful to actually. There are certain packages that need to do something when they're loaded. Like they need to actually go and create a temporary directory, or they need to create some C-level data structure for caching objects or something. And they need to initialize themselves in some way. And so if your package has a .onLoad function, it takes two arguments, but they're almost always irrelevant. Okay, so you just tend to write it like .onLoad equals function and ... If your package has that function will get called when it is loaded. Okay, so if the person attaches the package, they could call it that themselves. Okay, but we don't want to make every person call that function. But also, if it's loaded but not attached, they don't know that they're not there when it's loaded. So this will automatically get called. And there's a .onLoad as well. This can be very, very useful. Okay, if your package needs it. Okay, so so the .onLoad, this loading and attaching is a big deal. It tends to be minimal. How many of you have got C code in a package? How many of you have used a package with C code? You've got C code in your
I'm trying to write packages C++.
Excellent. Okay. So how you actually deal with RCP or how you write C++ code is a second. But the package needs to know about this. And there's two things I want to just mention about this. If you're writing a package that has C code, C++, C or Fortran code, okay, no big deal. You create another directory, src. Instead of R, you create a directory called src. You just copy all of your C code and C++ files and Fortran files in there, and you say, "Thank you very much, we're done." Okay, and R, the install.package or that R command install will automatically look inside that directory and then try to compile each of those files, and then it will try to actually glue them all together into a DLL, or a shared object, DSO, a compiled library. Okay, and the name of that shared library will be the name of the package. Okay, so R will take care of all of this for you. Yeah, and if it works beautifully. And if it doesn't work, well, you're gonna have to do something else. Okay, but we'll do well. But it's still the same thing. You put all of your compiled files into the src directory, and R takes care of it all for you. Life is great. The one thing you do have to do is you have to say, "I would like to use that compiled code." Yeah, so in the namespace file, you say use. Remember, we had export and export pattern, and we had import and import from. There's really only 5 verbs in the namespace. Okay. The fifth one is use DynLive for dynamic library, and you give it the name of the package. Okay. because that's the name of the C++, that's the name of the compiled code. Everyone happy? That's all there is to it. Except for writing the C++ code. That's another matter altogether. Okay? Okay? And you can do all sorts of interesting things with this downright function. Okay? But here's the bit that actually is useful, even if you're never writing your own. Even if you're never writing your own R package that uses C or C++ code. So what I basically said, everything will work. Okay? Everything will just work. If your C++ code, or C++, I'm just going to use the two interchangeably here, all of them. If that code just basically is standalone code, so it doesn't use any other functionality from your operating system, so it just can do, it does addition, it does basic math, it does some basic stuff. If it doesn't use any other routines from any other library that it would have to import, like we're now talking about C code, not R code, okay? If that's the case, you're good to go. It'll just compile. As long as the code is syntactically correct, it's all good to go. This will load the compile code into R, and you can just call it through the .c, .call, .fortran, whatever it is, okay? But oftentimes what you actually need to do is you need to customize that code you need to give it some additional compiler flags, okay? So you need, sometimes your code, if you know anything about C or C++, sometimes you use these preprocessor flags to say, oh, if enable R is defined or if it's not 0, then I do this code. Otherwise, I have a totally different block of code. Okay, so we can activate, we can enable or disable certain pieces of code, or we can, okay, depending on what happens. So we need to actually get that down to the compiler, but remember, we're not calling the compiler. We just say R command install, and it goes off and reads our R code, it reads our help files, it reads everything, but it also looks in the src directory and compiles all the Fortran C and C++ files for us, then it links them together. Okay, we're not there when this happens. So we need to actually leave instructions for the compiler to actually use. So we have a file called makevars. Okay, if you know anything about makefiles, this is part of a makefile, but we use it for very specific things, which is just to specify two flags, or two variables: package CPP for the C preprocessor, flags. Okay, we say this variable is equal to some hideously long, stupid string that no one understands and all that. Okay, so we can control the compilation. Okay, the author of the R package tends to do this. Okay, it's not you. Okay, however, if you need to screw around with it, that's where you change it. Okay, if you say, hey, I want to see if I can actually enable this. So that's what we actually do. So we put a makevars in. Now, I'm getting into the more complicated end of things here. If you don't know about C code, that's fine. But the thing is, a lot of the packages you're using have C code in it. So if they don't work, you can go off and go in and actually tweak things and actually say, let me fix this myself. I like to sort of be self-sufficient and autonomous. So I like to be able to go in and sort of fix things rather than say, it doesn't work, that's it. I'm giving up my PhD. Okay, that package doesn't work. Or even worse, that's it, that package doesn't work. Boy, it could take me 5 minutes to fix it. Instead, let me go off and implement it all myself for the next 3 years. Okay, so it's kind of nice to be able to go in and say, let me see if I can fix it. Okay, so it's good to know how these things work. You look at the makevars and life is good. Now there's two things. Okay, and again, I'm trying to tell you things that most people don't need, most people haven't seen, but they can be very useful. There are two types of flags. Okay, there are code, or package, code specific. Okay, this is basically saying I need to control through the compiler options. I don't want to go and change the code, but through the compiler options, I want to enable or disable certain features for the code in the src directory. And there's other ones which are compiler flags. Okay, that are for all packages. Okay, I want to turn on the debugging signals. I want to turn on serious optimization. I want to go to level 6 on optimization to get really fast code. Or I need to go off and tell the compiler certain things. For this, we change the src. This applies to typically when you're writing the package yourself. Okay, you change the flags in here, or if you're modifying, if you want to change this behavior as a user, you take the source file, you reinstall it yourself, and you just tweak this. But as a user,
If you want all of the packages to have debugging symbols, or I mean, this actually happens quite a lot. Instead of using GCC or G++, you wanted to use, or the Fortran F77 compiler, you wanted to use Gfortran or Clang or another compiler. Well, where do you set that? You can set it in here in makevars, but you typically want to use it for all packages. So what we actually do is, you have this, in, again, international symbol for my home directory. In a file, in a directory called .R, there is a file, you can put a file called makevars that is not dissimilar to this. And in here, you can actually specify variables like this. But you can also specify things like CXX equals Clang. Okay, you can put in things like CXX flags equals -G for debugging and so forth, and -06 for massive optimization, which will give us really fast code that gives us the wrong answers. Okay, so we can put in things like that, and we specify this sort of centrally for the entire system over here. Why does anyone care? I don't care. Well, I rarely use this. Why? Because I install my own version of R, so I get to control which compiler I'm using when I install R. But if you install a binary version of R, it may have been built and may have actually locked in that you're using GCC. And you may not have GCC, or you may want to use Clang or something else. This is a way of overriding this. I have multiple versions of different compilers installed, so I actually want to switch between. This is my way of actually overriding that. By not changing R itself, I'm not changing every single makefile file. But I set it over here. There's also over here, there's another directory called, another file called R environment. These are shell environment variables that get set when we build R. And then in tilde/.r, there's also a config file, which is used when we actually build R from source. So you can control all of these different things in different ways. Okay, but basically, this is where people control the compiler for the package specific code. Okay, now there's one extra piece of the puzzle. Again, I'm not expecting everyone to understand this and go, okay, yeah, that's obvious, or hey, and then most of you will say, I'll never use this until you do. Okay, so you basically do. If you have C code, and this applies 90% to C code, but actually applies to other things too, and that's the following. Oftentimes, I do not know what the right value is here for your machine. Okay? I actually need to enable certain pieces of code, or I need to link against certain. We also use this for linking against particular libraries. Okay? So if you look at this, this is one of those, this is my minimum compile package. This is all on the Git repository for this workshop. Okay? Okay, we didn't need a makevars for this. That was absolutely fine because there's just nothing to customize. But if we look at this is a package that Matt and I wrote, but this is the minimal version of it. It links to a C library, a C++ library called Tesseract. That's installed on my machine. It's a third-party library. So here's my makevars. I need to say, look for the header files for the C++ code here, and also in these two other directories. And then I need to do the same thing over here for the libraries that it needs to link against. How do I know that they should be there? So I need to basically say, you need to find these header files for C++ code over here, and they're in my home directory. Now you don't have a home directory called users Duncan, do you? Anyone? Okay. Okay. And you didn't know where these two libraries were to link against. I hard coded this. This will not work on the machine. Probably might do, but it probably won't. Okay? So this is really annoying. If I write code for you, you go, great, I really want to use this package. You download it and install it. Okay? And it doesn't install. Well, first of all, you can go into this make thing and you can change, this is what I mean by actually changing the makevars. You can just fix this makevars file. And it will work because you follow the readme file, but you tweak this. The right way for me to have written this
was to look on your machine and find out where the header files were and where the libraries were, and to actually dynamically determine these directories. Yeah, does that make sense? And this makes, now, writing an R package is hard. Writing a portable R package that will actually interrogate somebody else's machine and figure out what it's looking for in a reliable way has now upped the ante a lot, okay? But it's very, very important. When you install R, if you ever install R from source, it's kind of fun, okay? And I'll show you, like, we can show it on pretty much any piece of software. You just say configure, and it goes off and it computes. And sometimes it'll compute for 5 minutes. And it goes off and it looks around for absolutely everything. It says, you seem to have a weird version of the math library. Well, we have to fix up certain things for that. You don't have the regular expression library, so we use our own. You do have the JPEG library, but not the PNG library, so you can't have any support for PNG. You have the chirographic stuff, but it only has certain support, so you have to turn off half of this. So it basically is tailoring itself to your machine. How does it do that? Okay, let's go back up to here. Here's another package that does this. Okay, again, minimal package that just incrementally goes here. What it does is we use these things called a autoconf, okay? Autoconf is this weird thing. There's other versions of it, more modern versions, but this is what we use. Anyone recognize this? Anyone recognize this? What language is this written in? M4, but what's so the overall file is written in M4. What's this? What does this language look like? Bash. It looks like a shell script, not even bash, just regular sh. Okay, basic bourne shell. Okay, so this is big, and basically what we got here, we've got a file here that is essentially a shell script with a few extra frills that make our life easier, because these are not part of. This is not part of the shell, but this is part of autoconf. The AC stands for auto configuration, and we can go in here and we can do a bunch of stuff. There's a big collection of libraries that make our life easy. We're basically going in and saying, we're basically going off here and say, go find the command called pkg-config. Okay, this is a really useful thing. Package config basically says, there's a way where we install a piece of software, and then we can ask our system, do you have that piece of software installed? If so, can you tell me where the libraries and header files are, and any command, any options we need to compile it with it, and what version you have, and we can do all sorts of things. So it's metadata about install packages. So we use this. But the basic trick is, this is what you write. This is what we write for very portable code for R packages. If your package only has R code in it, you're lucky. You're very, very lucky. Well, you're not actually, because that means you have to write all the code yourself. Okay? If there's a nice C library over here that you could use, you'd like to interface to it. Okay, and then you don't have to write half as much code. You can just use that, but then you have to worry about the installation. That means you have to make sure that the user has installed it, which is you have to find it. Because people may have, just like we install our packages in different places, people can install libraries in different places, and they need to be able to tell you where they go. And we need to go find them. So this is the whole point of the auto configuration. We will go and try to adapt our make vars file and other things to know about your machine, okay, and to customize it to the peculiarities of your machine, okay, and that's all we do. This is a hideous language, okay. Shell is not graceful, but this takes it to a whole extra level of annoyance, okay. And what we actually do is the following, okay. Let's just take a look. Again, I'm telling you this not so that you will rush out and write one of these, but that you know that you can, okay. If we look at our min tesseract dyn conf, okay. What I actually do is I write that file, that configure.ac file. I write that and I run autoconf. Okay, so let me just clean up here, configure here. I'm just going to get rid of that. Okay, there's no configure file here. By running autoconf, that configure file got generated. My little shell script that I wrote in the configure.ac for autoconf is now turned into this hideous beast. Okay, the word count for configure.ac. The word count is 30 lines, which is a lot, which is really annoying. Okay,
But the word count for this is, anyone want to guess? 100?
Okay, oh my God. Okay, it's beautiful. We didn't write that. It just generated all this code for us, and it goes off and does exactly what we asked it to do.
And now when I actually do this, this is what actually, when I run this, so the other thing is I do this, let me just go over to here. Okay, I'm going to clean up in here. Okay, let me just get rid of these things. We should have actually cleaned those up when I installed this package, we should have cleaned them up.
And you should have. In fact, there's a mechanism in Art when you install that. There's a cleanup. You can actually have a cleanup file, script that cleans up everything. And you can tell the R command install and clean it up, please. And the reason, and this is a good thing, because the next time you reinstall, it'll leave all this leftover stuff. And if you reconfigure, it can get itself out of whack. Okay? So here's what we're going to do. Let me just do this. Watch what's different here. See this? This is all the usual stuff. This bit here is when we're compiling the C code, but all of this stuff is coming from the auto configuration. And it's actually basically off, hey, I found your C compiler, your C++ compiler. It accepts the -G, okay? It doesn't know about cross-compiling, so we're all good to go. So it's doing a whole lot of interesting things here. But this is the ultimate of actually making an R package flexible and adaptable to another machine. Okay, so there's one other thing that I just want to throw out there. There's a lot of other things we could talk about. One of the things you put when you write tests, put them in the test directory. Just have a file that says library my package, and then just runs code, and it should basically say stop. If not, there's a function called stop if not. If this condition is not true, so you just raise an error and you die. Okay, and that's a good thing. How many of you know about Travis CI and other things? Okay, this is a kind of a useful thing. Is you can go overboard. It's just a helpful thing. When you make a commit, that's a very useful thing. When you finally got something, you finished writing your code, you commit to GitHub or something like that, because you should be using version control. Okay. Before you commit, you should run R command check. Okay, and there's a command. Okay, so it's written in the notes here. This is the guy. Okay, R command lowercase check my package will actually go through and run the installation, the compilation. Okay, it goes through and it runs your examples, your tests, and actually then goes up and checks your documentation. So you've been very bold and you document this particular function, that particular function, and so on. Okay, and you run through all of this stuff. But this guy will actually do this stuff automatically. I tend to like doing it manually, so I don't commit stuff when I'm there. Okay, and then later on, when you're actually getting down to some of this stuff, this is how you actually collect a package up and actually give it to other people as a source package. Okay. So they can get it directly off of GitHub if it happens to be on GitHub. If you don't want to put it on GitHub, that's fine. But R command build, and you do this, and you get a .par.gz file. Suppose you didn't put it on CRAN, and you don't, there's another thing we will do here. I can also say R command install -- build the package, and that will create a .tgz file. And on Windows, it'll create a zip file. They're the binary versions. Okay, so that's now you know how to create a binary version. Okay, R command install -- build. Okay, you can't really do it from within R command. It's easier to do it from here. Okay. Now, one last thing. How do you distribute those binary versions? The simplest way is to put it on CRAN and have CRAN build for you. Okay. Be prepared to set aside a day or two to actually discuss with CRAN what changes you might be asked to make. Okay, they can be quite picky. Okay, about how to actually get stuff. You run R command check. You run and you get rid of every warning, every error, and every note. And then you upload it to CRAN, and even then they say, I want a letter from your mother, your grandmother. Okay, and so they're good guys, but there's good reasons for all these checks. But you can actually distribute this yourself. If you have a web server, you can do exactly what CRAN does, which is not called CRAN. You're not mirroring all the CRAN packages, but you can actually pop these things into a directory structure on the web server that people can then say install.package repos equals DSI.edu/r. And it will just go off and look for binaries or to look for source packages. And you can just do this. There's a function in R. Remember, I wrote up here, I started writing tools, 3: write _ packages. You may have seen me like this, but I wrote it earlier, okay? That's the thing, it actually looks at a directory, looks for all the packages in it, and builds a table of all the packages, and that's all we need. That and the tar.gz files and the tgz files. But you can actually distribute these things yourself. So you don't, so if this, and one of the reasons we care about this is, if this is a proprietary piece of code that you don't want people to, so you can't put it on GitHub, because now everyone can see it. If it's got proprietary data in it, but you want to distribute it to people, you may actually need to build your own binary versions of it. You need to be able to distribute it only to people who have access within your local network or something like that, or who have access to your website. You can do all of that stuff. Okay? So there's nothing stopping you by. Yeah, I'm not saying it is actually trivial. Is it, do you have to know, yeah, you just need to know the directory structure. It's really simple. I could give you a shell script that would actually construct it for you. Okay, it's a 2-liner. Okay, it's really not a big deal. But you can actually do everything we do and all that stuff. But there's one other thing which we didn't talk about this, and I hate talking about it. It deserves exactly 1 minute. Okay. There was one field in the description file that I glossed over intentionally. Anyone recognize that it was in every single darn description file? It's the license file. You better be very careful. How many of you signed an agreement with the University of California that says you don't own all of your code? You all kind of, I'm pretty certain that it's been a long time, but there used to be a document, and maybe you remember, there's a document where you actually have to sign allegiance to the state of California. Yeah. And underneath there, you also signed something to do with IP. Be very, very careful with licenses. Okay, there's all sorts of licenses, and in these slides, there's a link to the licenses. There's no point in getting a piece of code that has no license, because you have no idea whether you're entitled to use it. Okay, and if you use it, somebody could then come along and sue. So you need a license ahead of time. So you look at it and go, okay, it's BSD, that means I can do basically whatever I want, except I'm not allowed to use it. Use their name in marketing or advertising. There's Creative Commons, there's GPL, there's LGPL, these all. If you get a GPL piece of code, you better be very careful that you obey the license requirements. Okay, it's a wonderful license, but it has very specific requirements. But you also need to worry about your employer's IP arrangements, because you almost definitely signed something. That says you didn't, but I bet you did. I bet you somewhere in there there's some agreement. And I'm not even sure if you have to sign something anymore. So be very, very, very careful about this stuff. But you do actually, but there are good reasons for keeping code silent, invisible. You don't get the academic credit for it. Nobody can see it. Although you can always say, well, I have this wonderful code. You should see it. It's wonderful. It's the best code ever. But you can't, I'm sorry, I'm not allowed to show it to you. But you can actually still distribute it locally through binaries or anything like that by setting up your own repository. But if you want to talk, if you ever want to talk about licenses, no, I know a little bit about it. We actually have somebody downstairs, Mr. Wolf downstairs, who's a lawyer whose job it is to advise people on some of these things and all that sort of stuff. But it's a very, very serious issue as to actually that we tend to gloss over. How many of you have ever used software and not checked the license? We just do it. I know you all do, and I also know that you all click and yes, I accept the terms of service and all that sort of stuff. Everyone does. Well, let me set aside a day to learn, can I actually use iTunes? Okay. But for code that you're downloading for your work, we still do this, and it's really worthwhile looking at the license. And when you distribute stuff, you better put a license on it, or else you're actually really limiting the use, because people should be very careful. Okay. Cool. So anyway, we'll have another workshop next week. We have to decide exactly what's on. Cool. Thank you.